in last class we have completed the atomic structures chapter. So in this video I will start the new chapter, classification of elements. So here first you have to know the what is an element. Element means, so it is the basic unit of any chemical substance. So pure chemicals are divided into two types, elements and compounds. So in that, element means it is made up of similar type of atoms. Similar atoms. Suppose if you take hydrogen element means it is made up of all the same type of hydrogen atoms. So compounds means different. So compounds means, suppose if you take carbon dioxide. Carbon dioxide substance, how many elements are there? Carbon is there and oxygen is there. So it is the example for compounds. Elements means similar type of atoms. Hydrogen element, sodium element, like that. Sodium element means it contains all the sodium atoms only. So this is the element. And these elements are, so up to now we discovered so many elements, above 100 elements. So we need to classify them. It is difficult to study the properties of that elements without any classification. So why we need classification? To understand the elements properties, we need classification. So many classifications are there, but in your syllabus the Mendeleev modern periodic table is there. So in before Mendeleev modern periodic table there is different classifications are there that you don't need. So this is a modern periodic table classification. So here Mendeleev proposed the modern periodic law. So this modern periodic law is proposed by actually Moseley, the scientist Moseley. So what he did, Moseley? So Moseley recorded the X-ray spectra of substance. So up to that period, there were no structure of particular structure of elements. So at that time, Moseley discovered that, proved that properties of elements depended on the atomic number. So properties of elements depends on atomic number. He proved this by X-ray spectra. So he recorded the X-ray spectra of some substances and he proved that the frequency of emitted X-ray radiation. So just he taken the substance and he incident light has given the spectra, emitted spectra. So some light is given to the substance and it emitted some radiation, that X-ray radiation, and he recorded the X-ray spectra. So from that he proved that frequency of X-rays depends on the atomic number. Atomic number means number of electrons or number of protons is called atomic number. So here the line passes through origin and here frequency is directly proportional to the atomic number of substances. So here the frequency depended on the atomic number means here properties of elements depends on which thing? Atomic number. So this is the fundamental property of substances. Atomic number is the most fundamental property of the substances. All the properties mainly depends on the atomic number. So based on this experiment, he modified the periodic law. That modified law is called modern periodic law. So what says? Modern periodic law states that the physical and chemical properties of elements are the periodic function of their atomic number. Periodic function of their atomic number means properties depends on the atomic number. So atomic number means number of electrons or number of protons in a neutral atom, that is called atomic number. So here this is the modern periodic law. Based on this modern periodic law, he classified the elements in increasing order of atomic number. Let us see the periodic table. So here he classified the periodic elements into based on their atomic number. He arranged them in increasing order of atomic number. So let us see this periodic table. So here the horizontal rows. So here horizontal rows are called periods and the vertical rows are called groups. So this is a Mendeleev modern periodic table. Horizontal rows are called periods and vertical rows are called groups. So let us see how many horizontal rows are there. So there are 7 periods are there and 18 groups are there. Vertical rows are called groups and that are 18 and horizontal rows are called periods and that are 7. Good morning students. So in last class we have just given the introduction. So in this video I will explain the modern periodic table or long form of periodic table. So many classifications are there, but this is in your syllabus, long form of periodic table. In long form of periodic table, horizontal rows are called periods and vertical rows are called groups. So total 7 periods are there. So in these 7 periods, in the first period, the orbital subshell is going to fill is 1s orbital. So because it is lowest energy orbital, the electrons first enters into the 1s orbital. So how many electrons we can fill in s orbital? 2 electrons, means here in the first period 2 elements are there. And the second period, in the second period 2 subshells are there, 2s and 2p. So in 2s 2 electrons will be filled by 2s subshell and 2p total subshells are 3 subshells. So total here the 2 electrons and 6 electrons, means here 8 elements are there in the second period. So if you take third period, the electrons enters into the 3s orbital and ends into the 3p orbital. So 3s to 3p. So here also 8 elements are there in the third period. And next fourth period starts with 4s orbital, filling of 4s orbital, and after 4s orbital the next higher energy orbital is 3d orbital. So 3d orbital, then 4p orbital. So here 18 elements will be there in the fourth period, and fifth period also same. So here also the elements start from the fifth subshell. So here electrons will fill into the 5s orbital and ends with the 5p orbital. So here also 18 elements are there in the fifth period. And the sixth period, here the electron starts from 6s orbital and ends with the 6p orbital. So here the 32 elements will be there in the sixth period. And seventh period is incomplete period. So here 7 periods are there in the modern periodic table. And 18 vertical rows are called groups and 18 groups are there. So let us see. So this is how we can remember this. So by using this diagram. Already we have discussed this diagram. So to remember the subshells, to remember how to write the electronic configuration, you should know this diagram. So first electrons fill into the 1s orbital and followed by 2s. In the second period 2s and followed by 2p. In the second period. This is the first period, second period, and in third period the electrons enters into the 3s orbital and then 3p orbital, and then electrons goes to the 4s and then 3d orbital, and this 3d orbital will be filled by 10 electrons, and next 4p and next 5s, and in next 5s, after 5s 4d. So if you remember this diagram, it is very easy to remember the electronic configuration and also number of period and group. So this is the way to remember the electronic configuration. Or subshells, the preferred subshell after to fill the electrons. So this is the useful, very useful for your to write the electronic configuration. And if you see the modern periodic table, so this is the modern periodic table. Already we have discussed horizontal rows are called periods and vertical rows are called groups. There are 7 periods are there, and here the first period contains only 2 elements, hydrogen and helium. So this is the 1s1 and this is the 1s2. and the second period starts with lithium 2s1. So 2s1 to 2s2 beryllium, and then boron, carbon, argon. In neon 2p shell will be completely filled, and next third period starts with this element and ends with 3p orbital. So like that, if you remember this table, so it is very easy to remember the starting orbital and ending orbital. So it is very easy to write the electronic configurations also. So here like that 7 periods are there, and in 6th period and 7th period some elements are kept under the periodic table. So because of different properties, they will show different properties, that's why they are kept under the periodic table. These are called F series, 4F series and 5F series. And here in the middle of the periodic table, 3D orbital starts here in the third shell. So this 3D series, it is called 3D series, and it is called 4D series, 5D series and 6D series. So here d orbitals will be from the third shell, 3D orbital. So like this horizontal rows, 8 horizontal rows, and here 7 horizontal rows and 18 vertical groups. So here first A group, second A group, third A, fourth A, fifth A, sixth A, seventh A, eighth A group are 0 group, and third B, fourth B, like that. Total 18 vertical groups are there in the modern periodic table.